Hello all. Today we are going to see question number 41 of mechanical paper on GATE 2020. So basically you are given this particular system and beam, and then you are asked what is the magnitude of reaction force at joint C. So important thing to notice is it has a hinge joint. So this question becomes a little trickier than the normal problems. You can check out more detailed concepts about this particular topic in NPTEL lecture Mechanics of Solids by Professor M.S. Shivakumar from IIT Madras. So before going into the problem, we'll look into few useful data. If you are given a bar with a uniformly distributed load Q, you can see, and it has length L. So the moment about this point A is given by Q into L square by 2. Okay, so we'll look into the problem how even this is being utilized. So let's go ahead. So this is the system given. So since you are having a hinge joint at this point, you can see. So let's let's just separate these two bar members. Let me draw it as A. So this is your A, B, and B, C. So why have I drawn this separately is that we are given a hinge joint at this particular point. So what happens at hinge joint is the net force at hinge joint, it is a flexible, it is basically a very flexible member. Okay, so unlike other support points, it cannot take moment or net force. Let's say it's a net force and net moment, these two quantities has to be zero at that point. So if you actually separate these beams out, so let's say since you're having forces like this here, you can write let's say RB like this. Okay, so now here I'm not considering any force in your x direction. Let's say this is x direction, only considering y direction. So let's say in y direction considering this, so net force at this point B is 0. That means here I'm going to have a opposite side RB. So when you join these two and make it a pin joint, your net force is 0. That's why. So similarly, I'm not going much detail into solving this part. Why, I will tell you. The question is you have to find what is the reaction force at this point C. So basically like I said, your moment at point B, that is your hinge joint, is 0. So I can solve this particular equation to get the RC. So I don't need to go for resolving this particular side of the member. So in case they asked you something regarding point A, so you would have had to go towards this point also. But here the question is a bit more easier because they have asked this point. So let's go more detail into this problem. So now considering first okay, so let's consider the moment of RC. So let me take like this. So now you're having RC and you have length to be 4 meter. Okay, so this is your point B. So what is it telling you is it has a moment like this because the force direction is like this. So basically it is going to rotate like this about this point. Let me consider this direction to be positive. That means moment at this particular B due to RC is RC into the distance 4. Okay, positive. Now let me take the second one. So I am having the point here. I am having uniformly distributed load 10 kilonewton per meter. So now what is uniformly distributed load? Zone. That is, now I am having something like this. Let's say my forces are going to be uniformly distributed like this, right? B, C, 10 kilonewton per meter. So how can I equivalently represent this? If I consider only point B, okay. So how you can represent this is, you have some force which is acting at, so you had some L, so it is going to act at L by 2. And what is that force? Your force is going to be F into L. That is, if this is your F and this is your L, 10 into, what was your L? 4 meter. So 4. So this is how you equivalently represent when you consider point B. Okay. And so now what is going to happen here is, so your moment is going to be in this direction, which is negative, unlike previous case. Your moment is going to be 10 into 4, which was your force, into L by 2. L by 2, since it's acting at the middle, so L by 2. So which is going to be 2. Okay, so this is your second quantity. So now we know that the net moment at that joint, that was B, is equal to 0. That means you have a negative of this quantity, 10 into 4 into 2, and positive of previous quantity, that was 4 into RC, that is equal to 0. So when you actually solve this, what you're going to get is RC is equal to 20 kilonewton. So now RC is positive, that means we took this as the direction of force, so that is the positive direction. So your forces is going to be like this for RC. Okay, so one thing to note is, even though I wrote this as force F here, it is actually some quantity that is Newton per meter. So it is basically distributed throughout the length. So it's equivalent representation. When you write it like this for particular point. So if you write for particular point C, you're going to get similar thing, but instead of moment like this, since now the point is C, the moment is going to be like this. Okay, so it was a fairly simple problem. So I hope you understood the problem, but I recommend you solve even complex problem than this to get accustomed to such complexity. But in this particular case, the problem looked complex, but it was fairly easy once if you know the basic concept. So thank you all.